All right. Now we're going to discuss what exactly R is. So R is a programming language. It was first developed in the 90s as an update to an earlier programming language that's called S. There's a lot of similarities between the languages because R is simply just a newer version of S. But beyond just being a programming language where you can code, R is also a free, open source software environment. It is more than just the language itself. It is the software that allows you to use various functions and whatnot, and also allows you to write your own functions and upload them to the Comprehensive R Archive Network, or the CRAN, where there's tons of extra kind of R packages that you can use, and we'll discuss more about that soon. R is very popular. It's one of the most popular programming languages at the moment, and its popularity is on the rise, which is really phenomenal and very interesting because R is a specific programming language, not a general purpose programming language like many of the other common ones like C or Java or Python. There are three main advantages to R in my view. These are easier data wrangling, more ethical science and more ethical analysis, and more sophisticated analyses. So breaking these apart, I think that easier data wrangling is the main advantage to using R. If you're going to switch over to using R in your own work, this should be the number one reason that makes you do so. Whenever I was an undergraduate, I spent countless hours, days, working in Microsoft Excel, manipulating data for my thesis, copy-pasting things, highlighting, moving around, dragging, writing little scripts and functions and whatnot in Excel to do things. It took a long time to get my data into order, into shape, into a form that I could then run my analyses. Organizing and sorting and classifying, manipulating these large amounts of data in something like Excel is incredibly time-consuming when done by hand. And not only is it time-consuming, but the more that you are copying and pasting and dragging and dropping and highlighting and everything, the more room for human error there is. All sorts of errors can pop up just through simple mistakes because you're really playing with your data a lot more than you would with something like R. And so these errors get introduced. R permits you to much more quickly and much more reliably manipulate and clean and sort and categorize your data. This is, as I said, the number one advantage. I can't tell you how many times I've encountered people who are spending literal days sorting through spreadsheets in Excel, trying to clean up data sets, and doing things that could be done in literal seconds with an R script. It would save so much time if this were just done in R. The second advantage to using R is more ethical data science. Reproducibility is becoming a really big issue in a lot of different fields at the moment. And this is the idea that many of us learned in grade school science class, that whenever you run a scientific experiment or an analysis, somebody else should be able to come along and reproduce your results. They should be able to replicate your analysis. And this sort of idea has been introduced into archaeology and forensic anthropology and many other fields lately. A key part of this concept of reproducibility is having reproducible data management and statistics. You don't want to rely on button-clicking software like SPSS or Excel or something like that, because this makes it really hard for people to recreate your analyses. Right? If you use something like ArcGIS to run spatial analysis, you're going to end up clicking a lot of different buttons with a lot of different drop-down menus and doing a lot of different things, and then trying to describe what you did in your methods. No matter how good you are at describing what exactly you've done, there's a very good chance that somebody will come along and not be able to figure out exactly what you did. And perhaps even more importantly, you might come along later and not remember exactly what you did and not be able to reproduce your own analysis. With code, when you start using statistical programming, all of this becomes much more easy to replicate. You can just run your script again, and because that code is all still there, and hopefully you wrote it well and it's still operational, you can replicate your analysis far more easily. And you can also allow other people to reproduce your results as well. You can share your code with others, with collaborators or people who are simply curious. You can post your code as a supplement to any publication. You can upload it on your own personal websites. This is truly the most ethical way to engage in science because it allows others to ensure that you are running analyses correctly and appropriately, and they can borrow your methods themselves even for their own work. Additionally, accessibility is a key part of this as well. Unlike a lot of very commonly used statistical and other software, R is free. Right? R is a free open source language and environment, and so anybody can come along, regardless of your personal wealth, your institutional wealth, and you can download R and use it. That is not the case for a lot of other software packages where you need to pay hundreds or perhaps even thousands of dollars in licensing fees in order to use the software. R is entirely free, and that opens up a whole world of possibility, and it opens your work up to others who couldn't afford that kind of very restricted access to a lot of software programs. So this accessibility is a huge part of the advantages of R. The third reason that I would recommend that folks use R is for more sophisticated analyses. This is not as big of a concern for a lot of folks who don't need to use sophisticated statistical analyses. I think that being able to manipulate your data more easily and engage in more ethical, reproducible science, those are the biggest benefits of transitioning to use R. But sophisticated analyses is also important. One thing that could help a lot of people is automation, right? As I mentioned, instead of having to go back and try to remember what you did to run an analysis by clicking all the same buttons again and using all the same drop-down menus and tabs, if you've got an R script already written, you just, with a single keystroke, could redo your entire analysis and rerun everything. This becomes particularly important if you've completed an analysis and then either you find more data or a co-author comes to you and says, hey, sorry, can we add in this extra set of observations? Then you would need to go back and click all those buttons again, right? Run that whole analysis again, try to remember what you did. With R, all you do is load the new data with the extra stuff you've added, and again, a single keystroke, and you can recreate your entire analysis. It's so much easier once you start automating your workflow in this way. Second, you can use more complex statistics. A lot of people don't necessarily need to, but a lot of pre-packaged statistical software that others use really only includes the most basic statistical techniques. You'll certainly find very common things like t-tests in a lot of different software packages. But if you start getting into some higher level statistical analysis, it's simply not going to be possible with things like Excel or SPSS. That more complicated and more sophisticated statistical analysis at this point in time does require coding. The mathematics, the statistics behind a lot of scientific fields are advancing so rapidly that the cutting edge, and kind of beyond just the cutting edge, the increasing standards of what a good analysis looks like is getting to a point where coding is pretty much required because these statistics are becoming more complex. And finally, opening the black box is really important. A lot of statistical software that you have to pay huge licensing fees to use is just a series of black boxes. They've got their proprietary code. They don't share their code with you. You can't go and see what exactly a function is doing because that's secret. That's proprietary code. With R, nothing is proprietary. You can open up any function you want, crack it open, you can change it yourself, you can see exactly what's going on, exactly what parameters are being used in a model that you're building, for example. There is no black box in R. It completely does away with that. And this is not only opens up more options for you as somebody engaging in data analysis, but it also kind of makes things a little bit better in that you actually know what your analysis is doing, or somebody else can figure out exactly what your analysis is doing. It avoids this issue of proprietary code and various parameter settings that you're not really quite sure what they are in some of these proprietary software packages. That can introduce a lot of problems, and so just avoiding it altogether by using a programming language like R is very advantageous. Now, of course, a lot of these advantages that I'm discussing are not specific to R. Any programming language that you want to use is an improvement over button-clicking software like SPSS or Excel or ArcGIS or something like that. R is simply a particularly well-established and increasingly popular programming language, and one that is specifically intended for statistical analysis. It is open source. It has a huge community of very helpful users. There are countless blog posts, blog series, tutorials, websites, videos, everything that you could possibly want has been out there. There are more than 10,000 packages created by users and uploaded to the CRAN that you can download. R is very compatible with a lot of different operating systems and other software packages. In my own work, I combine R with several other different software environments, and they interface very well with each other. And finally, it is a statistical programming language, unlike a lot of other things like Python, which is the next, or kind of the other most common language to run statistical analyses in. Python is a general purpose language, which has its advantages and makes it much more broadly useful. But R is specifically a statistical programming language, so it is meant to run statistics, meant to run models, meant to manipulate and work with data. And that has its advantages too. But there are also downsides. R is slow compared to other programming languages. Now, of course, as I said, it's going to save you potentially dozens or hundreds of hours in comparison to manipulating data by hand. But compared to some other programming languages, R is relatively slow. It's still very fast for most of our purposes, though. But it is slow, it's memory intensive, it's decentralized, and there is a steep learning curve. And these are all downsides to using R. And because of that steep learning curve, my goal in this module is not to teach you everything about R. It's not to teach you everything about statistics. My purpose here, as I see it, is to help you learn the terminology, to acquaint you with a basic familiarity of what R is and what statistical options you have, and to demonstrate to you how you can help yourself, right? You are inevitably going to forget many of the things that you learn here. What you need to retain, however, is the feeling that R is not so scary, that statistics is not so bad, and that you can figure this out. You also need to retain some of the terminology, right? How to run Google searches for the problems that you're encountering. That requires some basic vocabulary that you need to be familiar with, pertaining to both R and to statistics. And so I really encourage you to pay attention to the terminology that is used in this module, because you are going to end up helping yourself. I cannot express to you how important it is to remember that a huge part of programming is done on Google. No programmer out there actually knows everything about their language. No statistician knows everything about statistics. All of us are Googling things. We all forget exactly how to specify the parameters of a certain function, or what exactly some type of probability distribution is that we're using. And so it's for this reason that you really need to pay attention to the terminology, because this is what provides you with the search terms that you're going to use whenever you also encounter these difficulties and have to turn to Google yourself. You certainly aren't going to remember much from this course. You need to do things yourself. The best way to learn R is not to watch videos or to click through tutorials. The absolute best way, and in fact I think the only way that you will really learn how to use R and how to do statistics, is to do it. You need to commit to yourself that from here on out, all future projects that you work on, you will do them in R. You will complete all analyses. You will manipulate your data exclusively using R. That is how you become good at this. That's the only way that you're actually going to learn permanently the things that you need to know in order to become a data scientist in this sense.